So far we've learned about force. We've learned that force is a push or a pull on objects. And not all forces are created equal. Some forces are much stronger than other forces. And in order to help us compare forces, we need to have some common unit. The unit we use to measure force is called the Newton, in honor of Sir Isaac Newton, a really important mathematician and scientist from the 1600s and 1700s. We named the Newton after him because he published the 3 laws of motion, which are 3 really basic rules that help predict motion on a big scale all across the universe. The force of 1 Newton on your hand is like the force of something that weighs 1/4 pound resting on your hand. A force of 100 newtons would be like the feeling of something that weighs 22 pounds resting on you. Force can have a magnitude. It can have a strength to it. We can have weak forces, 1 newton. We can have strong forces, 1,000 newtons. But there's more to force than just magnitude. Force is a vector quantity. And who better to introduce what a vector is than the man himself?
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! It's so difficult sometimes to get the piranha back inside.
So as Vector just showed us, being a vector is more than just about magnitude. It's about magnitude and direction. So in physics, we represent force with an arrow, because arrows can show direction. How can an arrow show magnitude as well? The length of the arrow. Which of these vectors do you think represents a stronger force? I hope you selected the longer arrow. Okay, so let's take a real-world example. Let's say you have a hamburger and a person applies a force of 5 newtons towards the right. We would show the force by drawing a vector and labeling it with the magnitude. So even without the image here, I would know that something is getting pushed or pulled to the right with a force of 5 newtons. The net force is the total amount of force acting on an object. It's pretty straightforward to calculate the net force when there's only one force. That is the net force. But what if there are more than one? Let's say this person pushing the hamburger is opposed by another person who's pushing on the hamburger with an equal force. We can represent this situation with 2 vectors showing equal magnitudes but opposite direction. So in this situation, are the forces balanced or are they unbalanced? They're balanced. That's because the 5 newtons to the right is canceled out by the 5 newtons to the left. Now, if we wanted to look at this in a more formal way with an equation, we can calculate the net force. Now, if we were to just add 5 newtons and 5 newtons and get 10 newtons total, that would be an unbalanced force, which means that this hamburger would start moving. But that's not the case. Balanced forces help keep an object motionless. So instead, we say that one of the directions is a positive force and the other is a negative force. That way, when we add them together, they can actually cancel each other out. Now, just by convention, we've decided that to the right is positive and to the left is negative. So now we end up with positive 5 newtons and negative 5 newtons, which is the same as saying 5 minus 5. Net force of 0 newtons means a balanced force. Let's look at a different situation. This person's pushing 5 newtons to the right still, but now the other person has doubled their force and they're pushing with 10 newtons toward the left. Are these forces balanced or unbalanced? They're unbalanced. The net force is not 0 newtons. And if we wanted to calculate the net force, since 5 newtons is towards the right, that's going to be a positive 5. And since 10 newtons is toward the left, that's negative. So you could either do 5 minus 10 to get negative 5 newtons, or you can just find the difference. 10 minus 5 is 5 newtons, and then add on the direction of the stronger force. 5 newtons left. What's the net force acting on this candy cart? 50 newtons to the right is a positive 50. Add it to the other vector, negative 200 newtons because it's pointing to the left, and we wind up with negative 150 newtons. Or if you're more comfortable with just finding the difference and then naming the direction, you could take the larger force, 200 newtons, subtract the smaller force from it, and find your difference. But now in this method, we just have the magnitude, we don't have direction, so we have to actually say left. Go ahead and pause the video to try these out, and then unpause to get the answer. So in this first one, 8 newtons to the right and 8 newtons to the left. To the right is a positive 8, and to the left is a negative 8. When I add a positive 8 and a negative 8, I get 0 newtons. And even though force is a vector, so it has magnitude and direction, when the net force is 0, there is no force, so there is no direction. All right, this one. We have 6 newtons to the right, so that's a positive 6. And we add it to negative 10 newtons to the right. That's the same as 6 minus 10, which gives us negative 4 newtons. Negative 4 implies it's to the left, or we could write this just as 4 newtons left. Next example, 8 newtons to the right, 5 newtons to the left. Adding positive 8 and negative 5 is the same as subtracting 5 from 8, so we end up with 3 newtons, or you could write 3 newtons right. And last one, 7 newtons to the right and 4 newtons to the left. When we add those together, it's the same as 7 minus 4, so we end up with 3 newtons, or 3 newtons right. All right, here's a new situation. This boy is experiencing 2 pulling forces, and they're both going in the same direction. So 450 newtons to the right, so it's positive. Another 450 newtons to the right again, so it's positive. We end up with 900 newtons towards the right. When vectors are pointing in the same direction, the only thing we can do is add them. So our answer is either 900 newtons, which implies it's to the right because it's positive, or we could say 900 newtons right. Okay, let's get a little bit more practice adding and subtracting. Go ahead and pause the video and try all these, then unpause for the answers. There are multiple ways you could tackle these problems. What I'm going to do is just add up all of the vectors, paying attention to the right being positive and the left being negative. So 8 newtons to the right is positive, plus 10 newtons to the right is also positive, plus 8 newtons to the left is negative. And I end up with 18 newtons. So my final answer is 10 newtons, and that's to the right. Next problem. 6 newtons to the right is positive, plus 8 newtons to the right is also positive, plus 10 newtons to the left is negative. And 14 plus negative 10 is 4 newtons to the right. Next problem. 8 newtons to the right is positive, 5 newtons to the left is negative, and another 5 newtons to the left is also negative. So now we have 8 minus 5 is 3 newtons plus negative 5 newtons equals negative 2 newtons, or 2 newtons left. And we've already seen this one before. 7 newtons to the right plus negative 4 newtons is 3 newtons to the right. Okay, so all of the examples so far have been on a horizontal plane, but let's look vertically. What's the net force acting on this book when you consider gravity from the Earth and the support force from the shelf? Just like how before people decided that to the right is positive and to the left is negative, people have decided that up is positive and down is negative, which actually matches how we talk about things. When you climb a mountain, you gain elevation. When you go down the mountain, you lose it. So our support force is up, so it's positive, 10 newtons. Weight, the force of gravity, is pulling down, so that's a negative force. We end up with 0 newtons. Or the other method, since they're pointed in opposite directions, I can just find the difference. 10 newtons minus 10 newtons, 0 newtons. No direction required because it's a balanced force. In every example so far, we've seen forces either acting in the same direction or in opposite directions. But now, they're at a 90-degree angle from each other. So how do we figure out what the net force will be? The answer is geometry. So in this example, we have an airplane who has a net force in the forward direction of 5,000 newtons, and it's experiencing a wind to the right with a strength of 100 newtons. If we create a rectangle that is as tall as the forces pushing the plane forward, and it's as wide as the forces pushing the plane to the right, and then we connect the two corners to find the diagonal of this rectangle, this vector right here is called the resultant, and it shows us the net force. But how do we figure out the magnitude? We can see the direction. Well, since this is a rectangle, that means all these corners are 90 degrees. So this right here is a right triangle. We know its height, 5,000 newtons, and its base, 100 newtons. And this is the hypotenuse. If you want to figure out the hypotenuse, all you need to do is use Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the two sides of the rectangle, and c is the hypotenuse. So 5,000 squared plus 100 squared is c squared. 5,000 squared is 25 and 6 zeros. 100 squared is 1 and 4 zeros. And I'm going to jump on over to my calculator to find what the square root of 25,010,000 is. And if I round, I get an answer of 5,001. So that means my resultant vector is 5,001 newtons in that direction. All right, let's try another example. This is a toy plane that is getting pushed forward with a force of 3 newtons and towards the right with a force of 4 newtons. What's the direction and magnitude of the net force? Pause the video and try it for yourself. Unpause for the answer. So the first thing I'm going to do is set up my rectangle. Now I'm going to draw the diagonal of the rectangle because that is the resultant. So now I have the direction, but I still need the magnitude. So that's what I'm going to use Pythagorean theorem. My two sides are 4 newtons and 3 newtons. So 4 squared plus 3 squared equals c squared. That gets me 16 plus 9 equals c squared. 25 equals c squared. And the square root of 25 is 5. So I label my vector with 5 newtons.